Good morning, my YouTube viewers. It's Crystal here. I'm here this morning because I wanted to do a code review on some code that I've written on how to use DictVectorizer. The reason why is because I'm creating a course with Udemy on natural language processing, and at the last minute I decided to include this in the course on how to use DictVectorizer. And basically, I've not made a code review on it on the past, so I thought, well, this will be a good time for me to make a code review on it now. So we're going to use DictVectorizer and sklearn's machine learning library, and this little program that I've written. The first thing we're going to do is we're going to import the libraries that we're going to use. So import pandas PD, which is a data frame library which enables you to create and maintain data frames. And then we're going to import NumPy as NP, which is a numerical, which enables you to make numerical computations, and it also creates NumPy arrays, and you're also able to do linear algebra with it. So we're going to create a dictionary. Dictionaries are used to store data values in key value pairs. A dictionary is a collection which is ordered, changeable, and do not allow duplicates. Dictionaries are written with curly brackets and have keys and values. So we're going to create a dictionary called Dict. That's called DICT. And then after we've created our dictionary, we're going to use the DictVectorizer. And then I got that from sklearn. There's some text here from sklearn, but I'm not going to read very much of it. I'll just read the first little bit. The class DictVectorizer can be used to convert feature arrays represented as lists of standard Python Dict objects to the NumPy SciPy representation used by scikit-learn estimators. While not particularly fast to process, Python's Dict has the advantage of being convenient to use, being sparse. Absent features need to be stored, and storing feature names in addition to values. DictVectorizer implements what is called one-of-k or one-hot coding for categorical, aka nominal discrete features. Categorical features are attribute value pairs where the value is restricted to a list of discrete possibilities without ordering, e.g. topic identifiers, types of objects, names, etc. And there's some more information on DictVectorizer as well. But what I'll do is I'm not going to read it, because when I did this course, I read a lot of information, and when I did it, I thought to myself, oh, they're not going to like that, but I'll find out if they don't like it. But if you want to know more about DictVectorizer, you can go onto the sklearn website, and they will tell you everything you want to know about DictVectorizers. So we're going to, from sklearn.feature extraction, import DictVectorizer. Vec equals DictVectorizer. Vectors equals vec.fit, transform dict to array, fit to data, then transform it, and then here's your vectors. And so it creates a sparse array. So after we also did a get feature names out, and so you can see all the feature names. And then we did a shape of the vectors, which is 11 rows by 23 columns. So the 11 rows was all of the people that I added. And then after we vectorized it, we're going to use TF-IDF transformer. I'll read just a tiny little bit of this, and if you want to know more, you can go onto the sklearn website and research it, and they give you everything you want to know about it. But the TF-IDF transformer transforms a count matrix to a normalized TF or TF-IDF representation. TF means term frequency, while TF-IDF means term frequency times inverse document frequency. This is a common term weighting scheme in information retrieval that has also found good use in document classification. The goal of using TF-IDF instead of the raw frequencies of occurrence of a token in a given document is to scale down the impact of tokens that occur very frequently in a given corpus and that are hence empirically less informative than features that occur in a small fraction of the training corpus. So you can read the rest. You can go onto the sklearn website and it's in there if you want to read it. So now what we're going to do is we're going to transform it. So from sklearn.feature extraction text import TF-IDF transformer, TF transformer equals TF-IDF transformer dot fit vectors, word count vec TF equals TF transformer dot transform vectors, and then word count vec is TF shape of 11 rows by 23 columns. And so we're going to create a data frame. DF0 equals PD data frame word count vec TF, and it says to array. So if you want to see all of those, because this is something that I did in the last video. View. Okay. No, that guy won't give it to me. Okay. Here we go. So what we're going to do is just going to make it to where you can view all the columns. So yeah, so now we do, so to view all the columns, you do pd.set_option display.maxColumns none, and that allows you to view all the columns. And after we've viewed all the columns, then we'll sum it. So dfo_sum equals df.sum, and axis equals 1 df_sum, and you can see all of the columns or all of the rows have been summed up. So that's it for DictVectorizer. We've made a little program. We've made a little program for TF-Vectorizer so you can see how it works. But what the vectorizer does is it converts every word or punctuation into a vector, and then the transformer takes every vector that's been created and gives it a weighting. So you get the DictVectorizer works with the TF-IDF transformer, just like the count vectorizer works with the TF-IDF transformer. And so one little piece of information, you've got the TF-IDF vectorizer. What that does is that does the same thing that the count vectorizer and the TF-IDF had previously done. So it does all of that in one function, whereas previously you had two functions. So this is just a little bit of a code review to show you how to use the DictVectorizer, which is used in natural language programming if you ever want to use it. So thank you very much for watching my video. Thank you for my subscribers for supporting me. If you like this video, please like, subscribe, and share. And I look forward to making more videos for you in the future.